Alright, hello everyone, this is Mr. Crozier. I'm going to go over worksheet 1.5, infinite limits. I'm going to do problems 1 and 2. Directions say analytically find any vertical asymptotes, then verify it graphically, numerically. Alright, so problem number 1 says 5 over x minus 1 is our function. Well, how do I find limits analytically? One thing, I look for a number c over 0. Any number over 0 except for c cannot be 0 itself. So anything over 0 will get me that asymptote. Well, let's work on this denominator. X minus 1 needs to be 0. Solve the equation. X is equal to 1. But let's test that. If I plug in 1, I have 5 over 0. Therefore, that's our asymptote. All right, let's verify it graphically. Graphically, I press y equals, put in my equation, 5 divided by the whole denominator. Make sure you have the denominator in parentheses. And I'm going to hit zoom. 6 is just standard. There's my graph. And yes, absolutely, it appears at 1 there is this vertical asymptote. Now, on your graph, you have to have a number here and a number on the x-axis. I put this value -5. If I trace this, hey, there's a good point on the graph right there. Input 0, output -5. There's a point. Always try to do one number on the x-axis and one number on the y-axis at least. All right, but what about tables now? We've done it analytically, graphically. Now let's do tables. Let's look at 1 from the right side. So I go to second table set. Let's have it ask for inputs. Right there's table set. Now let's go to our table. I'm going to delete all those values. Let's try plugging in 1. Well, that's an error, of course, because it doesn't exist. That's why we have an asymptote. Now let's try numbers that are a little bit bigger than 1, like 1.1, then 1.01, and let's just keep getting closer to 1. And look what happens as I keep getting closer to 1. These values keep going up. So here's my table. As I get closer to 1, this goes to infinity. And that's what you see in this graph. As I get closer to 1, it goes to infinity. But now what about the other side? Let's delete that. 1 is still an error, but 0.9, 0.99, 0.999, 0.9999, 0.9999, these keep getting closer to negative infinity. They keep going down forever. And that's what the graph is showing. Analytically, graphically, with a table. For your tables, 3 points will be sufficient. All right, on problem number 2, we have this equation. Well, let's do it analytically. Analytically says I just need the denominator to be 0. Well, that would be a -4. Now I do f of -4 is -8 over 0. This is the case that sets up an asymptote. There's my asymptote. Let's verify that it's done correctly with a graph. X plus 4, graph, and yeah, right here at -4 is an asymptote. And if I just click over, I can see where -4 is right there. I can count it. There's -4, and that's right where that asymptote appears to be. If I want to do it real neat, I could hit Window, change my X scale to 4, and then look, this is 0, -4 right there, -8 right there, counting by 4s. So the x-axis is now counting by 4s, the y-axis counting by 1s. All right, now again, let's do a table. Second table, let's delete all of this. -4 is where that asymptote is, and now let's go -3.9, then -3.99, -3.999, -3.99999, and look at that, it's 8 times 10 to the 7th power, a very large negative. Now what about the other side? -4.1, -4.01, closer, -4.001, -4.001. And let's get a really large number, -4.000000001, and it's too big for our calculator. That was a little bit too much for it. 8 times 10 to the 8th power. And you notice your calculator rounds over here on the left. All right, and there's another problem. We found the vertical asymptote analytically. we verified it graphically, we verified it numerically. Our three ways to analyze calculus. All right, hope this helps with your homework.